Up until now, we've talked about 3 ways that you can solve a quadratic equation. You can factor it and make a t-chart to solve. You can graph it and look for its roots, look for where the graph crosses the x-axis. And we've also learned that you can plug it into the quadratic formula. Now, today we're going to talk about a 4th method we can use called completing the square. And it's pretty simple. All right, let's take a look at number 1. What we do is we just take the first term, the x squared, and the plus 6x and bring it down. Okay, we're going to keep the terms that contain an x on the left-hand side of the equation. Then what we're going to do is we're going to take our number and we're going to move it to the other side of the equation. So if you add 9 to both sides, that negative 9, when it's on the left-hand side of the equation, becomes a positive 9 when we move it to the right. All right, so now what I'm going to do is I like to put an empty box right here where I left a space, and we're also going to put an empty box on the right-hand side of the equation. Now we're going to put a number in that box, and to find the number that goes in the box, so to find this number that goes in the box, what you're going to do is you're going to look at the term before it, so the positive 6, and you're going to take half of that number, so take half of 6, and then when you're done, then you're going to square it. Okay, so if you take half of 6 is 3, and then we're going to square it. So 3 squared is 9. So we're going to put a positive 9 in this box. Now, in order to keep the left-hand side of the equation equivalent to the right-hand side of the equation, if we added 9 to the left-hand side, we have to also add 9 to the right-hand side. Okay, so from here, what we're going to do is on the left-hand side of the equation, you can just factor this. So this factors to x plus 3 times x plus 3, which we can just rewrite that. Whenever you have 2 of the same factors, you can just rewrite it once with a square on the outside. And by the way, you will always wind up with a repetitive factor when you're doing completing the square. Okay, and then on the right-hand side of the equation, just add 9 plus 9 is 18. So now, our goal is to get the x all by itself. So what we're going to have to do is we're going to have to get rid of the square on the outside of the parentheses. So to get rid of a square, you just take the square root of both sides. So the square and the square root cancel off, leaving us with x plus 3. And on the right-hand side, we have to be a little careful with this because whenever you take the square root, when you're solving and you have an x squared, like if you look in the beginning of this problem, it starts off x squared. Whatever the biggest exponent is, that tells you the maximum amount of solutions you're allowed to have. And you have to solve for them all, and sometimes, you may have repetitive solutions. But in this case, we should have 2 solutions. So when we take the square root of both sides, it's not just radical 18, it's positive and negative radical 18. It's kind of like if you were solving x squared equals 9. When we take the square root, it's not just x equals 3, it's x equals positive 3 and negative 3, because 3 squared is 9, but also negative 3 squared is 9. So you always have to consider the positive and the negative. Okay, but anyway, back to our problem. So now we have x plus 3 equals positive and negative radical 18. Okay, so if you want, you can first we want to get the x by itself. You can subtract 3 from both sides of the equation, leaving you with x equals, usually write the negative 3 first, and then the plus and minus radical 18. Now, whenever you can simplify a number under the radical, you're definitely going to want to do that. So radical 18 breaks up into radical 9 and radical 2. So that'll become 3 radical 2. So what we're left with is x equals negative 3 plus and minus 3 radical 2. If you wanted to check this, you could plug this into the quadratic formula, and you would get the same exact answer. Okay, so let's try another one. Number 2, it starts off a little different because the first thing you want to do is you want to make sure your leading coefficient is a 1. So since we have a 3, what I'm going to do is I'm going to divide both sides of the equation by 3. So 3x squared divided by 3 is just x squared. 15x divided by 3 would be 5x. And 18 divided by 3 would be 6. And then on the right-hand side, 0 divided by 3, still stays as a 0. Okay, so now we're going to just do this the same exact way we did number 1. We're going to leave the x squared plus 5x on the left-hand side of the equation, and let's put an empty box there. And then we're going to take the positive 6 and move it to the right, so it becomes a negative 6, and let's put our empty box there as well. All right, so now when we look at the term before the box, it's a positive 5x. So we're going to take the 5, we're going to take half of 5. So half of 5, I'll just do this off to the side right here, would be 5 halves, right? 5 divided by 2. And then if you square that, what happens when you square a fraction is you square the numerator. So 5 squared would be 25. And you square the denominator. So 2 squared would be 4. So what we're doing is we're adding 25 fourths to both sides of the equation. And if we put it on the left, don't forget to put it on the right as well. Okay, now you may look at this and say, well, that's going to be a little bit harder to factor because of the fraction there. But let's look back at number 1. When we had to factor the x squared plus 6x plus 9, isn't this number that's in the second spot in our parentheses just half a 6, right? So when we set up our parentheses here with an x and an x, shouldn't the number that goes in the second spot in our parentheses just be half of this 5 here? So it's going to be 5 halves. And since it multiplies to a positive and adds to a positive, they're both going to be positive. Okay? And by the way, if you multiplied 5 halves times 5 halves, it would give you that 25 fourths. Okay, when you multiply fractions, you just multiply the numerator, so 5 times 5 is 25, and you multiply the denominator, so 2 times 2 is 4. Okay, so this wound up how we wanted it. We have 2 repetitive factors. So what we can do is we can just rewrite that as x plus 5 halves in one parenthesis with a square on the outside. Okay, so if we were to add these over here, let's see. I'm going to just write negative 6 over 1. So let's find a common denominator. So I'd multiply this by 4 over 4, which leaves me with negative 24 fourths. And then I'm going to bring down my positive 25 fourths. So when you add these, negative 24 plus 25 is 1, and you keep the common denominator, so we get 1/4. All right, so to get rid of the square, we take the square root. So that leaves us with x plus 5 halves equals positive and negative. Well, I'm going to simplify radical 1/4 right here, because when you simplify a fraction, when you simplify a fraction under radical, you just take the square root of the top and the square root of the bottom. So the square root of 1 is just 1, and the square root of 4 is just 2. So right now we have plus and minus 1/2. All right, so to finish us off, what we would do is we would subtract 5 halves from both sides, leaving us with x equals, and I'm going to write the negative 5 halves first, then my plus and minus 1/2. Now, we can combine these. So, I mean, you know, when everything's out of the radical, you're going to want to combine them and figure out what your actual 2 answers are. So, first thing we have is negative 5 halves plus 1/2. So, negative 5 halves plus 1/2 would be negative 4 halves, which negative 4 over 2 simplifies to negative 2. Okay, then we have negative 5 halves minus 1/2. So negative 5 halves minus 1/2 would be negative 6 halves. And negative 6 divided by 2 would be negative 3. So these would be your 2 solutions.